Swayam Prabha. Digital India. Educated India.
Now, quite often you will have a problem like this. Let us say I am just going to give a problem and ask you a question related to trusses. Okay. So, let us say I build a bridge let us say some bridge like this. Please remember all these nodes are pinned nodes, okay, and say let us say I have built a bridge like this. There is a force acting on this due to the vehicle moving on this. Let us say that force is P. I am particularly interested in finding out what will be the force in this particular member. In a design, let us say I have this question that is posed to me. I need to find out this load so that I can verify certain fact related to this. In the method that we followed, let me just number them. Let us say if it is A, B, C, D, E, F, G, H, I, and I am interested in the force in section GH. In the earlier method, what we did is we went by sectioning in such a way that each of the sections had one joint in it or one pin in it, and then we revealed all the forces that emanate from this joint and then solve the problem. But if we do that for this truss, I have just shown only 1, 2, 3, 4, sometimes the truss may have hundreds of spans, and if I need to find out a member force like this, it becomes a tedious task, right. Is there a simple procedure? The answer is there in the earlier statement itself. I did a section like this. Who prevents me from making another section which includes many joints? Okay. So, the question that I can ask is, can I section this truss that includes many joints The answer is why not? Okay, and that is what we are going to do here. Okay, and we call that kind of a method as method of sections. To me, it does not make a difference whether I did it like this or many joints at a time. I would call this is also a method of section, but a particular method of section. We called it as method of joints the earlier case. Okay. So, how do I find out GH? Of course, one of the important things that I have to do is I have to section GH, then only I can reveal the forces in it. Okay. So, one important thing I know is I have to section, I have to remove the supports so that there is no more attachment to the fixed frame of reference. What else can I do? I can cut in some way and take a block and look at the forces and see if I can solve for GH. Okay. I will just do a few cuts to reveal and explain to you this particular method. Okay. Let me just erase it and draw a fresh one. Now for now we can easily find out these two reactions. Okay, let us say the span is the same, let us say L, 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 L. Okay. Let us say the height is also equal to L. Okay. What we need to find out is this member force GH. So which automatically means that I need to section this GH. Okay. This is already known, this is already known by total equilibrium. How do I section? I can probably section in such a way that I take this side of it, or I could probably do like this, right. Let us see if that is a good section to find out the member force GH. Let me just draw that to make it clear. So I am just going to draw this section, I am going to call this section as 1, this section as 2. Okay. This is F, E, so we have D, we have G, this is cut, right. CD is cut. What else is cut? There is a member going like this, which is CG, that is also cut. So like before, let us just represent the forces because of this sectioning. GH will act like this. How do I know it acts like this? I will take the force to be emanating from the joint G. Similarly for this, the force is emanating from D. Okay, so I am going to call this as CD, and this is CG, force CG is acting on this. Okay, all are assumed to be tension. Okay, what do I want to know? I want to know this particular member force GH. Okay, but I have two more forces here. All the rest are known. EY is already known by earlier treatment of the entire body, and there is a force acting on G which is equal to P. Alright. How many forces are unknowns here? GH is not known, CG is not known, CD is not known, but I want only GH. Okay. Earlier we have done this particular exercise of finding out a member force directly. Okay. In this case, what joint will you take or what point will you take in such a way that I can get a single equation in GH? The answer is pretty simple. I will extend this force, find the meeting point. What is this meeting point? This meeting point is nothing but C, right, and if I take moment of all the forces about C, it will not involve CG and CD, which means immediately I can get GH. The rest of the exercise is simple. So let me take moment about C of this particular section 1, right. Let us say this is positive, this is L, L, and this is L. This is, if this is in static equilibrium, total moment at C is equal to 0, implies this about this point, this force is in the anti-clockwise sense, it is EY times the length, which is 2L. The other force that is existing is P, and that is in the clockwise sense about C, which is about L by 2 from C, and therefore it is minus P times L by 2. Is there any other force? GH is acting. GH is in the anti-clockwise sense and the height is equal to L, so which means it is plus GH times L equals 0. I know L. In this particular case I need not know L also. I can find out GH to be nothing but P minus 2EY. simple, alright. In a similar way, if I look at this particular section, I will be revealing the same 3 forces, okay, and I can take moment about C in order to solve for the same thing. In this left hand side section, I have only one force in addition to GH that I need to write down, okay, that makes it a little more simple, okay. So it is a matter of a choice, okay. Is there any other way by which I can section and find out this particular thing? The answer is, well, possible, but this is the simplest thing that you can do and you can immediately solve for this problem, okay. And this kind of solving is called method of sections, where you are interested in only one member force or a couple of member forces and so on, okay. Is there any other way of cutting? For example, can I ask you, what if I had cut like this, alright? Is this cutting okay? Not okay, because this is what we did for method of joints. We had to know the other forces in order to solve for GH. A sectioning like this is similar to sectioning like this, except that it reveals BC CH in addition to GH, and BC and CH are coincident at C again. So I will be taking moment about C, but for a section which is separated by this. So it will be like this. Is this clear? Thank you. Okay, now our student Venkatrao wants to know, if I have to find out the horizontal force members GH and DF, this and this I need to find out. Is there a way of sectioning by which I can solve for them in one single go? Well, that is a good question. Let us see. Definitely I have to cut this. I have to cut this. Okay. In what all ways can I go about doing this? Well, I can take something like this. Is it possible? Okay. In which case I will be revealing a force like this, a force like this, a force like this, alright, and a force along this, okay. If I take vertical equilibrium, this and this force will come into picture, right, which means I cannot take one single force in order to do this. If you notice, force FG, GH are coincident at this point, GC is also coincident, so 1, 2, 3 are coincident at this, but this force CD, DE and DF are not coincident, which means maybe there is no single sectioning I can do in order to solve this problem, okay. So what I could probably do, if I have to solve for this particular member, I can as well cut like this, okay. So I have revealed these 3 forces, okay, FG, DF and DE, and notice DE and FG are horizontal forces, and if I have to eliminate using DE and FG, I just have to take a vertical equilibrium, which means only DF, component of DF and EY will come into picture and I can solve for that. So the way to go about solving for DF in this particular case is sigma Fy equal to 0, okay. So you have to use a suitable equation in order to solve for the member forces, okay. So in short, you will find out an appropriate section, take a particular section which is simple, in which less number of forces are acting. If there are 3 forces like this acting and I want to find out one of the forces, then find out which equation will be the most appropriate to solve, and there you go. That is how you can solve for member forces. In order to solve for GH, you have already done that. You will take a section like this and then solve for it. Okay. So you need to do two separate sectioning in order to solve for this problem. If there are too many forces to be found out, might as well go for method of joints. Okay. How will I find out the force in this? I do not have to do anything. I can take the joint E and find out the equilibrium of joint E. Okay. So you have to use your judgment. Sometimes you may have to use method of joints in order to find out. After all, method of joints is nothing but sectioning in a particular way. Here sectioning is such that one joint is within. In the other sections that we did, we had more number of joints that get revealed or included.